Okay, welcome everyone. My script is here, so maybe I will look down there. Good morning, I'm Ted from Wiwynn. Today, I'm so excited to share the end-to-end storage, the story how YTL, Wiwynn, and NVIDIA work together. I think that's from the projects from 2024 until the last year, almost the whole year bloody journey for three parties to work together to build. I can say it's the first NVIDIA powered AI factory in Asia area. There's built lots of GB200 AI racks. Okay, let's talk about. The first thing is everybody wants to know more how to build the AI data center, or can call it AI factory. So let's go to the details we can share. Okay. The first thing is just showing these slides. You can see the first thing we want to understand why AI ready is not why the rack ready is not AI ready. That is still the gap we need to understand. When many projects celebrate the moment the hardware just installed and the bring up test is passed, so everybody claps and say, "Wow, okay, we're just finished our job." No, for the AI data center, AI factory, the power on and the test pass just only the simple baseline. From my viewpoint, the true AI readiness should be a cluster level of validation and the level 12 workload enablement passed. More importantly, it requires a proven and the real workload, the real work level stress test, especially stability over time. Our target is not just to deliver the racks. That's more simple and basic, so everybody just know that. We want to close the gap between the basic installation and the high performance repeatable commissioning methodology. So today I will show the methodology, the journey, make it like a blueprint that we can follow, repeat to build the next AI data center. Let's quick introduce the three parties, who does what. Okay, so in the slides you can see there are three companies. The YTL is a Malaysia-based data center. They build the infrastructure. They have their cloud operation as a NCP aligned cloud platform. For Wiwynn, maybe somebody knows, maybe somebody doesn't hear about our name. Wiwynn is a big hardware AI server building company, manufacturing company. But in this case, in this project, we not only deliver hardware, we also do some system integration job. We just work with NVIDIA. You can see in the middle, NVIDIA, especially with NVIDIA AI infrastructure service. So you will see the name NVIS in the later slides. We work together. So Wiwynn deliver commissioned system, do the testing, installation, and the final performance benchmarking. And NVIDIA just give us as a consultant role and provide some important software package from NVIDIA to build the cluster and make the validation. Okay, so finally everything ready, then YTL will go for the day two operation. They can provide their cloud service for everyone. Okay, right now let's go for the first. There are four phases for this journey, for this blueprint. Okay, we just follow, we work with NVIS, so they do provide the AI ready methodology. Okay, you can see there are four phases from the the basic one, site qualification. To the final phase, we do cluster proof and go to operation. Okay. Let me talk about the 4 phases. The first one is site qualification. We just want to understand how we can to configure to check that any facility ready. So in the later slides, we'll go some details. So phase 2 is rack and the networking integration. Then when the rack and networking are ready, it can be scaled, then we can go for the cluster configuration. Now, there's a lot of software job that have to do. Okay. Then if we confirm the cluster configuration ready, then we will do the final stress test, including lots of benchmarking for the real workload, AI workload. If we can prove the cluster can pass those benchmarking, that will say it's ready for the AI and for the AI factory to work. So you will see the YTL data center will be Malaysia's first NVIDIA powered AI data center that will build in Johor. Okay. So let's go for some overview, phase by phase. There's a simple table to show how the 3 parties work together and their working roles. I think the most important thing is just to clarify the roles for each party to provide essential service, doing their job in each phase. So building AI factory is not just about plugging the servers. There's a lot of things. So we work together to turn lots of components into the AI power racks and to be the AI factory finally. So the phase 1, phase 0 in the qualification, you will see majorly YTL will take care of the infrastructure. That's because the data center is built by them. And they will do some pod scope. You know what is pod? There's maybe 16, 32 GB200 racks work together as basically a basic unit. We call it a pod. So the pod scope, how many servers we should put into the data center zone and some networking architecture. So networking planning is also need to work with NVIDIA. NVIS suggestion. If we do finish the qualification jobs, then we can move to phase 1. Phase 1 means, okay, the real muscle, the rack, GB200 rack is manufacturing and the validation at the L11 level in Wiwynn's factory in Malaysia. So after the L11 testing finished, we will move those racks into YTL's data center and make test again. Configuration, finish the fabric networking installation, then test again. So in the phase 2, Wiwynn will do the power on test and the rack level leakage testing. I think that's more important for the liquid cooled servers. So we will do those tests in real data center environment. Then the YTL, well, as I said, they take care of the infrastructure parts. So power, cooling, some basic checks, the facility that will be covered by YTL. And the NVIS, they will help to do some hardware and some logic components deployment. So if we finish the rack integration test, okay, then we make sure the real cluster configuration can be ready. Do you know why? If we cannot make sure that the phase 1 is ready, so there was a lot of noise, like server issues, fabric issues. There's a lot of noise to go for the next one. So we have to make sure in the phase 1 is ready. So for phase 2, some important thing is when we do the BMS. BMS is support for the environment control. the most important thing is do the telemetry. We have to make sure the sensing data, including the thermal, the leakage, the power, that should be okay and collectible, observable by the whole system management interface. Then the power cooling validation. In this case, the validation should under the controlled stress. We have to do the stress test. In the phase 1, well, water, power, ready will be okay. But in the phase 2, it should be do the stress test. Then for NVIDIA, they have their very precious software stack they call it mission control. The mission control should be installed, deployed to do the test, stress test. So when we verify the cluster configuration is ready, then to the final one, that is the real workload should be tested. What kind of test we do the final one? For NVIDIA, you can see, maybe you know about that. They will do the LLM training test. We use a NeMo Megatron. So NeMo Megatron, by testing by NeMo Megatron is the first step. After that, Wiwynn will do the MLPerf benchmarking. Actually, by this project, Wiwynn just submits MLPerf training results based on GB200 racks, 16 racks configuration, and get a better results than NVIDIA's results. Well, that's we get a new firmware drivers, so can have a better results. However, there's a strong evidence to improve, to prove the AI data center, the AI phase is ready for operation. So when we close the cluster proof, then those servers, those softwares will transfer to YTL, so they can do cloud orchestration and cluster management for their daily day 2 operation. Okay. So site qualification. There are big three parts I had to follow: electrical, mechanical, including water and some power. Then operation. Operation, that means we need to have our engagement rule to do some update management, like a firmware, like a change control. So those will be checked. And phase 1. Phase 1 is to, as I say, do some integration. The major thing for phase 1 is the standardization. So we just lock the very important thing is you have to lock your firmware and the driver baseline to make sure that all the servers are just running the same firmware version, same driver version. Don't mix them up. Otherwise, there's a lot of noise. You cannot find what happens in the stress test. So make sure you lock down your firmware drivers baseline. And we have to verify some sensor, telemetry verification, as I say in the previous slides. And the most important thing is cabling. I would say more details in the next slides. Cabling is very important. It's a nightmare for all of us. Okay. Then the part layout rules. Okay. So when we finish the rack integration, let's talk about one of the nightmare about cabling. Okay. There's some things we need to do. I will not to talk about more detail. It's very professional, and I even not a professional for that field. But the most important thing is you have to clean. That's the lesson we get. every fiber cables you have to clean, use, and check by those code, those utility tools you can see in the slides. So clean is very important. You have to make sure everyone is clean and clarify it's okay to check the inspection. The fiber is okay for the signal integrity. So, yeah, okay. Next will be, so remember, that's term we want to tell. In this phase, cabling is quality. If you cannot make sure all cables are connected correctly and the signal integrity is okay, don't move to the next step. Otherwise, you will have to go back to check which line, which fiber is not okay, to dig out the issues, what happened. Okay. So another things we have to take care is liquid cooling. Okay. Wiwynn just developed a very cute small gateway. We call it UMS. They can take care the rack level liquid cool alerts. Okay. In the L10 level, the compute tray, the NVIDIA's design GB200 compute tray, they have the capability to support liquid cooling alert. However, outside the box, in the rack level, in the manifold, at the high, what can we do? So we have the liquid cooling alert gateway, and we use some leakage sensing band just right up on the manifold or anything you think leakage will occur. So by those hardware and software, and they will connect to YTL's BMS for notification. Then if any alert happen, then the top management software will decide how to do the policy-based action to shut down or turn off some power or utility. So that's we have to make sure to make text for this. This one is very important. We have to treat it like a fire safety. So everyone have to make exercise. When the leakage alert, how can we do? How to repair and fix these questions. Okay. Okay. So let's move to phase 2. So in phase 2, there are more software jobs have to do. You can see in the slides, mission control install. So there's a mission control software stack. So there's lots of software components have been installed. So including lots of GB200 servers, you also have you need to have another control servers to run those mission control software, like Slum, like some management. Okay, so we use Slum to do some workload deploy and some testing. In this case, the basic the testing will use the HPL link pack, okay, the high performance link pack and the NICO validation as a baseline. Okay. Then this page will talk about the important for telemetry. We have a white paper to talk about our experience, how to build a measurement framework in this case. So if you are interested, just go to Wiwynn's website. You can download the white paper. We talk about the things and some software we develop. So NVIS or NVIDIA cannot provide all the necessary software for you because you have to install lots of third-party peripheral components. So there's some management component you need to develop. I think is the key value for SI job. Okay. So for this one, I would say we want to do the fast triage isolate performance bottleneck by the the observability through the management telemetry. Okay, there's a plot diagram. It's simple to show what we did. So based on Prometheus, to do some, we will do some exporter to support some hardware. So in this one, you can see the whole framework work with BMS. So BMS will be here. That's more related to infrastructure. You can CDU, valves, and the IT gear, networking, and also the high-speed storage. So in the AI factory data center, not only the GB200 racks, we also have installed lots of high-speed storage for AI workload. So they all managed by this telemetry framework to see what's going on, including the hardware fail and the some workload bottleneck. Okay. In the phase 2 still lots of things to validate the power and the cooling under stress. Okay, so using the nickel and the HPL, we check the fabric topology and the system healthy. So in this case, the most important thing is we need to check the validation under stress, not a normal condition. And if you cannot make sure this, in the future workload testing, you will always find some ghost. Why I say ghost? You just something unstable. Lots of issues happen again and again. So you have to make sure the validation ready in this phase to make sure the baseline, everything is okay. Then we can go for the next stage. Okay. Finally, after several months hard work, we almost to the end point. But before that, there's still lots of things to do the final proof. We have to make some benchmark and the commissioning evidence. So there's a later graph to show the 3 steps we want to do. The baseline is still nickel. Why? That is, we have to verify the networking still correct. Again, okay, the fabric topology should be okay and healthy. Then go for NeMo Megatron. So realistic multi-node training, do some real-world training behavior. After that, we choose, for Wiwynn's viewpoint, we choose to follow the industry standard. We use the MLPerf training package to do the testing. And we believe after the benchmarking done, and we have a good number, those results, those configuration can be migrated to the new AI data center. So that's the evidence. We believe we have to follow the standard methodology. So if we can do it in YTL cases, then we can do it again in other data center to rebuild the whole process repeatably. Okay. So, that's the performance results. Well, we're still the best one last year. Well, even only a little bit better, but you can start right in a win-win. So the smaller number is the better for the AI test. So based on the NVIDIA GB200 racks, we have 72 72 accelerators base, and we also have 16 racks. The total over 500 GPUs. Then we also have a white paper to talk about that. So just download. You can see what we did for those AI clusters validation, the details. Okay, it's free. Okay. So based on Llama 2 70 billion parameters model. Okay. But don't forget the YTL's job. After we finish those testing AI workload validation, YTL also have a very big value for future operation. So YTL is our partner, is our customer. We work together. So YTL Cloud, they will provide the service from day 2 operation. Can do some commitment for sustainability, something like that. So YTL Cloud operation and the innovation will be also important in this case. Well, conclusion. Here is a blueprint. So to build the AI factory at scale, we have to deliver 3 things: repeatable, measurable, and operatable. I think follow the 3 words. You have to make sure you can rebuild the data center from one side to another side, and again and again. Okay. With the NVIS guided phases deployment, you need to do the stress test before scale up. Remember that. Stressed. Don't move too fast. Maybe your boss asks, come on, going faster, but be careful. Stress test and make sure the validation in your rack level is ready, your facility is ready. Then go for the next step for workload to do benchmark. That's very important. Finally, the workload commissioning and the evidence pack will be provided and to prove we can go the repeatable by design, by measurable by default, and we can operable. Okay. For this sharing, if you guys, you want to take one thing away today, I'll say being an AI ready doesn't mean the hardware is just installed. Okay, it should be proven with the confidence, like I say, the 4 phases and the steps to be ready. That will be validate to be okay, ready for day 2 operation. I think that's the experience we will learn from this project. Okay, I think almost done. I have to thank you, everyone. Even in the last day of this conference, lots of people stay here to listen me to share the experience. Anyway, we still have a video for you. Okay, let's take a look. Take a look at the video. That will show some jobs we did before for the AI server building testing. Okay. Come on. How can I play the? Okay, great. By the way, I have to say, the song, including the lyrics and the melody, as created by AI. Okay, that our Mac can't just do it. So enjoy. Coolant circulates through the veins, keeping energy and calm restraint. So you will see Vera Ruby. When computation strikes the limit, we break through physical boundaries amidst the surging tides of AI. We hold fast to the original intent of design. Well, it's a tough job to build the first Vera Rubin rack by your bare hands. Well, you have to assemble the whole thing. So our engineers just go to Malaysia's factory to build the first rack. So there's automatic manufacturing for the L10 system. So for Wiwynn's manufacturing, you can see we have many testing bay, lots of rack level testing in the factory. Okay. All right, I think we're done. So let's go for this one. If you have any questions.
Yeah, I can just hit the mic. You can just raise your hand.
Thank you so much. It's a great talk, and thanks for sharing all the details. You mentioned cabling as one of the pain points. I wonder if you would say, if in the whole process, thinking about the whole process, if you say that is the biggest pain point, and if that is the case, if you can share a little bit more about why it is painful.
Okay, let's go back to that page. Okay, this one? Okay. In the configure the whole thing, especially, of course, we have a partner to help us to deploy those cables. But the lesson we learn is, before you get each single fibers, you have to clean the MPO, the line, the endpoints very carefully, and test by those probe utility to check there is no dust, whatever there's a clean. Then you can plug the fiber to the switches. So that, I think that the step is very important. Since we have some bad experience, is the cleaning process is not good enough. So there's a lot of noise happen, and you will see in the validation testing, some link just suddenly drop. And then we have to find, wow, what's going on? What's going on in the NV link? Something like that. So after some experience we get, so then our operator, our engineer just follow, okay, just clean to make sure the signal integrity will be okay. Then go for the next step. So that's why I say that step, just it looks very simple, but you have to do that very carefully. Yeah. Okay.
All right. Yeah.
All right. So thanks for such a great presentation. So I'm really learned about the good things, good experience from your slides. So my question is the separation of the roles you suggested in this presentation. So you basically, so YTL, NVIDIA, Wiwynn, we have you have each organization have keep their roles and have their responsibilities.
Yes.
However, I really have the problem on the how we can expertise to. So we need still the ground design person to know whole stack of the cluster sometimes. So how we can deal with such a separation of the roles.
Okay. Actually, I'll say if you are the beginner, you are the first time you want to build your own AI factory, your AI data center, I strongly recommend call for help from NVIS. They are professional. They have a whole bunch of guidelines for you. There's a whole system of methodology for you to follow. And they have a software, they have engineers to help you to check your data center side, do the qualification. So you can, of course, you have a lot of things to do yourself, but follow the methodology, follow the guideline. And they will have a professional service to dig out, do some bug fix. Something like, I say the cabling. First time, we just cannot find what's going on, why. Then we find some suggestion in the guideline. And they can have some tools for you to test and narrow down the scope. Finally, we find, okay, the key issue and to fix it. That will speed up your deployment and validation speed. So I think that's my suggestion. However, this NVIDIA's event, actually they cost much. It's not inexpensive. It's expensive, so but it's worthy. I can say that, especially for the first time. But lots of things you still have to learn from them. Yeah, so I think we work together and have a very good time in this project. Okay, nightmare in the beginning, and finally we finished everything. Everybody are so happy. We built a very good example for the AI data center. Okay, yeah, yes.
Okay, so 2 questions. One is, how do you simulate the load in your evidence testing?
Load?
Yeah, you had load on server load and also cooling system. How do you simulate that?
Okay, there's tools from NVIS. Yeah, there's tools.
You mean like simulation tools?
No, this is a real test on the data center. Right, we use tools to test, not a simulation. You can see in the first, phase 0, the site qualification. Maybe you just do some simulation. Simulation will only in that phase to check any possible water, electricity requirement for the layout. That's the simulation. Okay. From the phase 1 to phase 3, we move the racks into the data center and do the assembly, configure the fabric, and testing the racks in the data center field. Right. So there is real test, but there is the only difference in phase 1 is the only stress test. You can see the basic validation. So just not the real workload. But in the later phase, that we will move to workload like NeMo Megatron or MLPerf training. So that's a different phases validation. Right. Okay.
And the second question was the latency result you had.
A latency?
Yeah.
Oh. This one?
No, you had a chart with latency. You said you were the best. It was 1.
Okay. Oh, this one.
That one, yeah.
Okay.
Which is that milliseconds or 1.39 milliseconds, or what unit is it?
Let me see. Minutes.
So 1.4 minutes.
Yep.
Okay.
You have a lot of things, the loops running and running. Yeah. So since GB200 is very powerful, right? So you have to accumulate many times to check, right? So so that's why I say smaller number is better since we go faster. So use only 1.3 minutes to finish the storage the testing package, right? Okay. Yep. Please.
Very impressive, Dr. Peng. My question is that you mentioned that you have this BMS job, the second phase, and also you mentioned that the YTL decided their BMS.
Yeah.
What are the BMS, the most important difference about this kind of super AI data center from the common data center?
Okay. BMS, the BMS is the name is building management system, right? It's a baseline, okay, for the data center. So except the IT gears, you need the BMS to check to the telemetry for all the peripherals, the facilities. And beyond that, the BMS will have an interface. You can see the mid-layer to connect, to interface with the monitoring function of IT gears. So we will treat the BMS well, the whole management system for the future operation. So they have different layers. You can see it's BMS plus. Okay, plus lots of extension module to monitor the IT gears. But maybe right now it's only for hardware for leakage detection. For workload, sometimes you can use other companies' solution, even from NVIDIA directly to check the AI, to check the GPU utilization, something like that. There's some package software we can use, but for infrastructure, for the facility, the BMS is a very important thing. Okay. No, not this one. Something like that. Okay. YTL has BMS is a very professional job. Wiwynn doesn't developer, but we did help. I see. YTL's BMS is a big one, and they have to connect to lots of facility and components. For example, CDU, Power Shelf, something like that. And by those framework based on Prometheus, you have to, we use Prometheus and Thenos. The hardware component have to provide the exporter. That means you can, we can do telemetry from that component. So if the hardware component vendor doesn't provide exporter, then Wiwynn can help to write the exporter for their devices. Actually, we did several cases to provide, we will help vendors to write the exporter or provide a template for them. Right? So we just try to fill the gap between the third-party vendors and the BMS framework. Okay.
All right. I think we have one final question.
So I have the questions. For the testing, the AI load will go up to peak is 165%, right? So how will you manage the load during the testing for the AI load?
Sorry, I didn't catch your question because I cannot see your files.
Okay, so the AI load, the peak will go up to 165%, right? The AI load.
Okay.
So how you manage during the testing? So UPS will handle up to 125, 150% load only. So how you manage that 165% load during the testing, the peak load?
Well, you beat me. I'm not professional for that detail. Maybe I can talk to our engineer to deep dive. Well, sorry about that.
Yeah, that's okay. So on one more question, how you are sizing the networking for the AI pod?
Okay, good question.
Yeah.
Actually, standard tools. Okay, in the class level, we can check pole to pole to check every connection. However, I think that's a very normal and standardized process. Yeah, just as I say, before that, you have to clean the fiber. Remember that. Otherwise, lots of errors happen. You don't know how to find the root cause where it happened. Right? Yeah.
All right.
Okay.
I think that's all the time we have. Thank you so much. Thank you, Ted, for the presentation.
Okay, thank you. Thank you, everyone.